Hi, let me introduce our project for you. Our project name is a comprehensive recommendation for music system. And we want to build a comprehensive recommendation system. We have to use different ways to recommend items. And we think for our system, it's a good way to use colors to show the features of music. And here's our data set. This is a rating dataset. We use play count as the proxy for ratings. And this is the song features. We use timbre average and timbre covariance of as our features. Here is our first algorithm. To calculate the timbre average, we must first calculate the male frequency scepter coefficients. We use this algorithm to calculate it, and then we can calculate timbre average and timbre covariance. And this is our second algorithm. The features we calculated above is too large, so we want to reduce them into 3 dimensions so we can show them in colors. So we have to use PCA to reduce the features. And here is our third algorithm. We use our features calculated above to denote the to calculate cosine similarity. And this is our last algorithm. This is a collaborative filtering algorithm. First, we must construct features of users and items with known ratings, and then we predict the unknown ratings with the updated features, and then we can recommend users with highest rated items. Yeah, here is we use ARS in PySpark to use the collaborative filtering algorithm. Here are tools we will use. We have used. First, we use scikit-learn to do PCA and turn it into RGB, and we use the package in PySpark to do collaborative filtering. And we also use JavaScript and HTML to build a web page, and we just save our data to MySQL Workbench, and we use Python 3 to write API functions. And we also use pandas and NumPy to do some data cleaning and processing. And here are our contributions.
So this is the principles and structures of our project. When users log in our uh, applications, they may receive several sounds. We recommend them based on the CF algorithms. And when they lab and click on some of the sounds they may like potentially, we can also recommend them with other similar sounds. So we used ALS package in the Spark in the first phase of our project. And as you can see that the RMSE is only about 13. That may be satisfying compared with the range of the plate counts in our dataset. And this is the final file what we get through the first phase. As you can see that we recommend each users with the top six sounds that they may like potentially based on the CF recommendation. In the second phase, we use the cosine similarity through scikit-learn. We found several similar sounds for each sounds, and also apply every sounds with the RGB features. This is very interesting because the similar sounds may share the similar colors in our project, and the users can find the similar sounds more easily.
So this is our application should look like. So when user log in our application, we will recommend them with some hardest sounds first, and then we also recommend them with some sounds they may like potentially.
based on the CF algorithm. And when users are interested in some of the songs, we recommend them. Here we also recommend them with some other similar songs. And as you can see that these songs share the similar colors. That means their styles and timbres are similar. So I think this is also the improvement of our application. We applied sounds with RGB features to help visualize the sound features more exactly, and also can help users jump into their favorite styles of the sounds directly. Uh, we also met some challenges in the process of the project. First, the size of the dataset is too big for our servers, and also I think the music feature selection is very complicated. We did spend a lot of time into the discussion of which kind of features we should take. And finally, we took the general tunes of the music as the features. And there are also some stuff we need to improve in the future. First, users may be overwhelmed by the different colors of the songs because we cite the similar songs with the similar colors. And to solve that problem, we could set the threshold of the values of the RGB features, and then cluster them and add the labels into that instead of setting colors directly. In the future work, we could also introduce the topic modeling into our applications. If we can fetch the dataset about the lyrics, we can do the LDA about that. And second, because people have the different moods in the different days, we can also introduce the sentiment analyze uh, about their tweets, and then I recommend them with the different songs in the different days. That's all. Thank you very much.